Every single day, we step into our kitchens and we basically become scientists. We're running all these little experiments with heat and ingredients to create amazing meals. But have you ever stopped to wonder what's actually going on when you cook? Well, today, we're pulling back the curtain on the hidden physics that makes all that kitchen magic happen.
So, pan fry, boil, roast, we all know these words, right? We know the techniques, but what's the real fundamental difference? Why does pan frying make a steak crispy while boiling makes potatoes soft? Turns out, there's a single set of rules governing all of it.
So, here's what's on the menu today. We're going to break down these classic techniques, what a really fascinating presentation calls the old styles of cooking. We're talking pan frying, boiling, roasting, the whole shebang. And we're going to uncover the physics that makes each one tick.
To really get what's going on, we have to talk about the rules of heat. And don't worry, this isn't going to be a complicated physics lecture. These are just the invisible forces that are at play every single time you turn on your stove.
And it's actually super simple when you boil it down. At its core, cooking is just the science of moving energy. It's about getting heat from a source, like a flame, and into your food. The how? Well, that's where things get really interesting. Okay, so how does that heat actually make the jump into the food? Well, the first way is the most direct one there is. Just think about that sound, that sizzle when food hits a hot pan. Yeah, that's the sound of physics in action. The scientific name for this is thermal conduction, but really all it means is heat transfer by touch. Imagine the little particles in your hot pan are just vibrating like crazy. When your food touches that pan, those super fast particles literally bump into the slower ones in the food, passing their energy along. It's this tiny, microscopic chain reaction that cooks from the outside in. And guess what? You're already a pro at this. Every single time you pan fry something or do a stir fry, you are mastering thermal conduction. That direct contact is exactly what gives you that perfect golden brown crust. Okay, but touching isn't the only game in town. Sometimes, instead of just passing energy from one particle to the next, heat decides to travel. It basically hitches a ride on something that's already moving. And this is called thermal convection. So picture this. When water or air gets hot, it expands, gets lighter, and floats up. Then the cooler, denser stuff sinks down to take its place, gets heated up, and rises again. This creates a current, this constant rolling motion that carries heat all through the liquid or air. And the absolute classic example of this in your kitchen? Yep, a pot of boiling water. Those bubbles, that rolling boil, that's not just for looks. Those are the convection currents, and they are working hard to spread heat around to cook your food perfectly and evenly. All right, so we've got heat by touching, and we've got heat that catches a ride on currents. But there's one more way, and this one is kind of like magic. This is heat that doesn't need to touch anything at all. It can literally jump through empty space. This is thermal radiation. You know how you can feel the warmth of a campfire even if you're standing a few feet away? That's it. Hot things, like a fire or the heating element in your oven, are constantly blasting out these invisible waves of energy. When those waves hit your food, bam, they transfer their energy and heat it up. And that is the secret weapon behind roasting. When you slide a chicken into the oven, it's not just the hot air doing the job. It's that intense thermal radiation from the heating elements that really does the heavy lifting. It's what's so great at browning and crisping everything up, giving you that incredible golden skin. Okay, let's recap. We've got our three big principles: conduction, convection, and radiation. Now let's open up the physicist's cookbook and see how these all come together to make the food we love. Because here's where it gets really cool. Cooking almost never uses just one of these principles by itself. The best, most effective methods are usually a powerful team-up of two or sometimes all three. All right, take a look at this. This is where it all clicks. Pan frying and stir frying, that's all about direct contact, pure conduction. But then look at boiling, deep frying, and even steaming. They're a double threat. You get conduction where the hot liquid or steam touches the food, plus you get those convection currents constantly circulating fresh heat. That's why they're so efficient. And then you have roasting, all by itself, relying on the awesome browning power of thermal radiation. And that's really the big takeaway here. Whether you're searing a scallop, boiling an egg, or roasting some veggies, you're not just cooking. You're a physicist in an apron, expertly manipulating the flow of energy using these three basic rules of heat. Now, this whole idea was inspired by a presentation we saw called Cooking via New Styles. And when we saw that title, well, it really got us thinking. I mean, If conduction, convection, and radiation are the old styles, what comes next? What new physics are we going to harness in the kitchens of the future? Now that is some food for thought. Thanks for joining us.